Good evening, everyone. Right. Welcome back to our sessions on Python for AI. So far we have understood topics related to Python, where we have understood what is Python, history of Python, then followed by the fundamental topics like variables, then data types, operators, flow control statements. Under flow control statements, we have understood conditional statements, looping statements, and loop control statements as well, right? And next to flow control statements, we have also understood the concept of functions. Am I right? So these are the topics that we have covered so far. All of them have been covered. And today we are going to start a new topic. It is NumPy. Okay, so one of the very important library package, okay, so that we are going to learn from today. So what exactly are we going to learn in NumPy? Let us understand this. So in NumPy, we'll be understanding the purpose of NumPy initially. Okay, next to purpose of NumPy, we'll be talking about the history of NumPy, like who developed NumPy, when it was developed, in which language NumPy got developed. Okay, what is the purpose of NumPy? We'll understand all the introduction part to NumPy. Okay, next to introduction of NumPy, we'll go and understand the advantages that we get using NumPy module. Okay, so we'll understand the advantages. Next to the advantages, we'll also talk about, we'll compare list and NumPy. Okay, so we'll actually understand the similarities and the differences between the list and NumPy. Post understanding the similarities and the differences, we'll talk about the number of approaches to create an object of NDarray. Okay, especially NumPy deals with arrays. Okay, so there are different approaches to create these arrays. We'll be learning all the different types of approaches. Then next to it, we'll also talk about, we'll understand different types of NDarrays. Like we have one-dimensional array, two-dimensional array, three-dimensional array. In the same way, we also have n-dimensional arrays. We have n-dimensional arrays as well. So probably we'll be understanding all these topics till here in today's session. But as part of NumPy, we are also going to understand indexing and slicing operations on NDarray objects. Okay, so how indexing and slicing can be performed? It is similar to list, but not exactly, list. Then we also have advanced indexing and slicing operations. We'll be understanding the advanced indexing and slicing operations. Post to understanding the advanced indexing and slicing operations, we'll talk about the arithmetic operations on NDarrays. On n-dimensional array, how to perform arithmetic operations. We'll understand. Post understanding arithmetic operations, we'll talk about statistical operations. How statistical operations can be done on NDarray. And finally, the sorting and deleting process on the values of NDarray. So as part of NumPy, we are going to learn all these topics in the coming few sessions. Okay, but today we'll start with the history of NumPy. We'll understand what exactly is the purpose of NumPy. Then next to it we'll be comparing the differences similarities and the differences between list and NumPy. Post understanding the similarities and differences, will also understand number of approaches to create NDarrays one by one. Right. So let me start with the purpose. I'll go back, but before that, you should get introduced to NumPy. So what exactly you are aware of NumPy? What do you mean by NumPy, guys? If you have any idea, yes, keep them in the chat, your messages, drop your answers in the chat. NumPy actually stands for numerical Python. NumPy stands for numerical Python, NUM, which is an short form of numerical, and py is Python. So NumPy means numerical Python. NumPy is one of the third party library. But is it an predefined module of Python language? No. It is not a predefined library within Python language. It is one of the third party library. And to install any of the module, we have the command. We have the syntax. What is the syntax? The syntax is pip install module name. Pip install module name. So in the same way, to install NumPy module, what will the syntax? The syntax will be pip install NumPy. It will be pip install NumPy. So in order to use NumPy in our program, in our script, we have to import NumPy. Before using NumPy, we have to import it. We'll understand how to import a module because we are doing it for the first time, right? So how NumPy will be imported, we'll understand. Then what exactly is a NumPy module? Means NumPy module is a collection of variables, functions and classes. Okay, together all of these as a as a package, you'll get it in a module. As a pack of variables, functions and classes, you're going to get as a module. So on day one also we have understood the same topic. What is a module? Module is a collection of variables, functions and classes. So in short, we are going to use these things whatever available in the module. Whatever are present inside the NumPy module, we are going to understand and we'll be trying to use them. Right? So let us talk about the history of NumPy. We understood NumPy is nothing but numerical Python. Right? So what is the history of NumPy? Is NumPy was actually developed using by studying an existing module. There was an existing module called numeric library. Okay, earlier there is a library called numeric library. Okay, so this is what actually has developed the NumPy. Okay, we have our person Travis Oliphant have developed NumPy. But what are the challenges that we have with numeric library? The numeric library module that was existing long back, it was unable to solve the complex calculations. The max calculations that we can do, these complex math calculations cannot be performed using numeric library. Okay, so that is where our Travis Oliphant have developed the NumPy module, which helped us to solve complex math calculations. So the challenge of numeric library was overcome by NumPy. This NumPy module was officially released in the market in 2005. It was developed in the year 2005. In what languages? In both C and Python languages. In both C and Python languages, NumPy has been developed. Right. So this is a brief history of NumPy. Right. Then Let us understand the advantages of NumPy. NumPy is better compared to other, you know, data structures. In a sense, in order to deal with arrays, okay, especially in order to deal with arrays like one-dimensional array or two-dimensional array or multi-dimensional array, we go with NumPy programming. We go with NumPy. The reason why we go with NumPy is NumPy uses very less memory. It consumes very minimal memory for large data sets as well. Even for large data, it consumes very less memory. Okay, and NumPy also provides very fast operations. It performs very fast operations. The reason behind why it is fast, because internally the data is available in the same address. Okay, the address will not change, guys. It is available in the same address, and it performs array oriented computing. It also performs array oriented computing. It efficiently implements multi-dimensional arrays. It is capable of implementing multi-dimensional arrays, and it can also perform scientific computations. That is what we have discussed. The reason why NumPy was developed is to overcome the challenge of numeric library. Okay, so it can perform scientific computations, and it is also capable of reshaping the data. We can also reshape our data. We can transform our data, okay, which is stored in these multi-dimensional arrays. So by keeping all these in mind, we have the advantages defined. We can, it is very convenient to work with matrix operations can be done easily. Okay, and it is very fast, even though the data is very large. Even though if you are working on large sets of data, yes, NumPy is very fast. So these are the list of advantages. Now let me compare list and NumPy. Okay, because NumPy will be similar to list. Okay, but there are some similarities and differences. Let us talk about similarities first. Between traditional list and NumPy module, the similarities are, if you take a list object. I hope you guys are aware of list object, right? What is the purpose of list data type? List data type helps us to store multiple values. Yes, either of same type or different type, which can store unique values as well as duplicates. Right? So it can store multiple values of same type or different type. These values can be unique as well as duplicates. So this is the purpose of list. In the same way, an object of NDarray can also store either the same type or different type values, which can be unique or duplicates. So this is the common point between list and NumPy. And both the objects, if you take an n-dimensional array or a list object, both of them are mutable. What do you mean by mutable, guys? What do you mean by mutable? Mutable is nothing but we can change, we can edit even after the object get created. So these are the similarities between the traditional list and NumPy module, especially the arrays. Okay, let us talk about the differences. There are a lot of differences between the traditional list and the NumPy arrays. So if you consider a list object, a list can store both homogeneous as well as heterogeneous values. What do you mean by homogeneous and heterogeneous values? Homogeneous means the values they belong to the same type, right? Heterogeneous means the values they belong to the different type, right? A list can contain both homogeneous and heterogeneous values. But if you take an object of n-dimensional array, NDarray, okay, it can store only the values of similar type. What does that mean? Even if you try to store the values from different types, internally what happens is all these values, yes, all these values will be treated as same type, that is object. Even though if you are trying to store different type values in an NDarray object, okay, internally the type will be object based. The type of all these values will be treated as object. Then on a list object, we cannot perform vector operations. Can we perform vector operations? No. When you try to multiply any integer, okay, when you try to multiply any integer with list object, the values, the elements present in this list object get repeated. But will they get multiplied? No, not exactly. But coming to an NDarray object, yes, we can perform vector based operations. We can perform vector based operations. When we are working on large samples of data, if we are actually trying to build a list based application, it consumes more memory space. It consumes more memory space. Whereas NDarray object will just consume less space. This is the primary difference between a list object and NDarray object. A list object will occupy more memory space, whereas an NDarray object will just consume only less memory space. List based applications, they are not efficient guys. They are not efficient. Why? Because the list object, these values take more time complexity for extracting. For extracting the values, the data, it takes more time. Whereas Numpy based NDarray objects, they just take only, very less amount of time to extract. The reason being, they are available at the same address. They are not like list. List objects are available at different address. So this makes the difference. Again, complex mathematical operations. If you want to go with mathematical operations which are very complex, the choice should be a NDarray object. The reason why is NDarrays can perform complex mathematical operations, whereas it cannot perform complex mathematical operations. Right? So these are the differences that we have between list and NDarray objects. Then, so far we are understanding that NumPy is efficiently handling the data, right? But what are the different approaches to create these NDarrays? In order to build an NDarray object, there are multiple approaches. Okay, so let us understand all the different types of approaches one by one, right? Yes, here are a few approaches that we have mentioned. We'll be understanding all of these approaches, how to create an NDarray object one by one. So NDarray is treated as a predefined class, like how we have the other data types. They are defined as a predefined class. NDarray is one of a predefined class of Numpy module. Okay, where it helps us to store the data in Numpy programming in the form of 1D, 2D and n-dimensional arrays. In the form of 1D, 2D and n-dimensional arrays. But how can we create these NDarray objects? Or we have multiple approaches. Here are a few. Using array function, Arange function, zeros function, ones function, full function and identity function. Okay, so we'll be understanding all of them one by one. Array function, Arange function, zeros function, ones function, full function and identity function. So let me start with array function. What is the purpose of this array function in NumPy? The purpose of the array function is it helps us to convert the traditional Python objects into n-dimensional array object. See, if you have a list object or a tuple object, okay, or set object or dict object, all these are Python objects? Yes. And if I want to convert these to NDarray, n-dimensional array objects, I'll go and use array function. What is the syntax for array function? Is numpy dot array of object comma d type. Why are we specifying numpy? Because array comes from numpy module. As array function comes from numpy, we should always represent the prefix. Okay, it is not actually mandatory. It is based on the type of import that you are doing. Okay, if you are importing the entire module, then this is how you have to keep the syntax. Numpy dot array of object comma d type. Object comma d type. Let us understand the syntax first of all. So here the variable name to which we are assigning will be an object of NDarray. It will be an object of NDarray. Then what is array? Array is a function. It's a predefined function of NumPy module. It's a predefined function of NumPy module. If you see here, I'm using the dot to represent the hierarchy. That means I'm using array from NumPy. Okay, what is the purpose of array? It helps us for conversion. If you take any traditional Python object and if you want to convert it into NDarray object, we can do it using array function. How? I'll just pass it. I'll just pass that Python object inside the array function so that it results me an n-dimensional array as output. NDarray will be written as output. So the object it represents here are the traditional Python objects, guys. The Python objects that we have here are represented by the object. Then what about D type? D type represents the data type. D type is representing what? The data type. Like int 8, int 16, int 32, float 16. So all of these are the internal data types of C language. Okay, even though if you are not aware of C language, that's not an issue, but these are the data types that are used in C language. So D type can take any one of these. It can take any one of these values, one of these data types of C language, right? So let me do one thing. I hope it is very clear, right? The purpose of array function is for converting any traditional Python object to NDarray object. I'll go back. I'll go to Spider so that we can understand how array function actually works. How array function works. Right. So I'm back to Spider. Initially, I'm focusing on array function. Guys, be active. From here onwards, I want your responses. Right. So first of all, before using array function, before I go and use array function, we know that we have to import NumPy. Earlier, when we are discussing about the introduction of NumPy, we came to know NumPy is nothing but numerical Python. Numerical Python. Then, in order to use NumPy, we have to import NumPy. We have to import NumPy. The module has to be imported. Don't get confused, guys. See, installing is different. Importing is different. When do we install it? When we don't have in our local machine, okay, in the environment, we have to install it. What is the syntax for installing? The syntax for installing any module is pip install module name. Right. So the syntax will not change. For any module, the syntax will not change. Only the module name will change. Right. So this is for installing. Only for the first time I have to install. Later on, if I want to use any specific module post installing, if I want to install, if I want to import NumPy, if I want to use NumPy, I have to import NumPy first. Okay. So what is the syntax for importing is import module name. Import module name. So here if you see, I'm importing NumPy, but in a different fashion, right? I'm importing NumPy, but I'm also providing an alias name for NumPy. Okay, I'm providing a shortcut, a nickname, shortcut name. What am I specifying here? The syntax is import NumPy as NP. What does it mean? You are importing NumPy and then for NumPy we are also providing a alias name. What is the alias name that I am providing? NP. NP. Okay. So this will ensure that the NumPy gets imported and also NumPy gets a alias name as NP. In this line of code, both import and as are two keywords. Import and as are two different keywords. So let me execute, guys. When you are trying to import any module, okay, in our case it is NumPy, right? When you are trying to import any module and when you have executed, if you find any error, if you faced any error, any exception was raised, that means the module was not installed, right? Especially if you get a error like no module name error, okay, that means the module was not present in your environment. Okay, so I'm importing NumPy first of all. See, did I get any exception? No, I haven't got any exception. NumPy got imported and this NumPy has an alias name as NP. No more NumPy is NumPy. NumPy is called as NP. right? Then what am I doing in line number 9? What are we doing in line number 9? What are we doing in line number 9? What kind of object it is? We are creating a list object. How do you identify it as a list object? The elements are comma separated. All the elements are comma separated and they are organized in square braces. So that means we are creating a list object and this list object is being stored in L1. What is the size of the list object? 6. Right? So when I say print of L1 comma type of L1, it will print this entire list object along with the type as list. The type will be list. Yes. Now, what am I doing guys? In line number 11. In line number 11, I'm using np.array. The function that I'm using here is np. What is np? np means numpy. np means numpy. Instead of using numpy every time, I'm going with a shortcut name, right? So np.array, np.array. Array is a function which helps us to perform the conversion, right? Any Python object can be converted to n-dimensional array object using array function. What is the object that I am passing inside? I am passing a list object. So this list object will be converted as a n-dimensional array object. Okay, so that means it gets converted as a one-dimensional object, a one-dimensional array object, and it gets stored in A. So in short, we are converting a list to array. We are converting a list object to array object. Right? So let me execute line number 11 and focus on the variable explorer. A is array. A is array object. But did I specify the data type? No. Even though if I don't specify the D type, it by default takes int 32. Int 32 will be used. Right? Then what if I print A and type of A? When I say print of A comma type of A, it will print the array object along with the type as NDarray. See, so this is my array object. If you observe, is it similar to list? Yes, it is similar to list. The only difference that you see here is it is not, the values are not comma separated. Focus within the console. If you see here, all elements of the array, they are organized in square braces, but they are not comma separated. So this is very important guys. And the type is written as NDarray. Yes, it's an array object. In the same way, let us go for one more conversion. But this time, what are we doing in line number 14? It's a tuple object. It's a tuple object where the elements, the values are organized in parenthesis. So T is an object of tuple. It's a tuple object with 7 elements. With 7 elements. Then I'm printing this tuple object along with its type. So it will return me the type as tuple. Okay. Then next to it, I'm using array function. I'm using the array function from Numpy. So this tuple object will be passed into it where the conversion will be done, and this tuple will be converted as n-dimensional array. It will be converted as an array object. And when I say print of a comma type of a, it will return me, the array object along with the type as NDarray. Clear? Like how we are able to use this array function? It's very simple, right? The purpose of array function is for performing the conversion. Any Python object, any traditional Python object can be converted to array object using array function. Right? Then, what are we doing in line number 19? Line number 19. Is this a dict object? Yes. I see keys, value, key, value, key, value, key value pairs. So it is a dict object of size 3. Done. A dict object has been created of size 3. What am I doing next to it? I am converting this dict object to array object. I am converting this dict object to array object by passing the dict object inside array function. When I pass it to the array function, so this will return me an array. Let me print it to the console. See. Okay, so that's how you can use the array function for converting any traditional Python object to array. So the syntax is also very simple, guys. Array function, numpy dot array function of object comma d type. Object comma d type. Whatever the Python object that you are passing will be converted as an array. Then next to it, what are we doing in line number 23? What are we doing in line number 23? What kind of object it is? It's a tuple object. It is a tuple object. And I'm passing this tuple object to array function so that this tuple object will be converted to an array. So the syntax is np.array of the object. Right? So this tuple object will be converted back to array. This will be converted to array. And where did we store it? In A. So let me print A to the console. Yes. So this is my array. And now let me use we have n-time and d-type shape attributes. Okay. Within NumPy, as we know that A is an array, we can directly use some of the attributes that we have from NumPy. Okay. ndim, which is an attribute which will return the dimension. What kind of array it is. Okay. It returns the dimension. Is it a one-dimensional array or two-dimensional array or three-dimensional, so on. Yes. So ndim will return the type of array. We know A is a one-dimensional array. It's a one-dimensional array that we have created from a one-dimensional object tuple. In the same way, there is an attribute called dtype. There is an attribute called dtype which will return the data type of the elements, okay, that are present in array A. So what is the data type? Did we specify any data type? No. Even though if I don't specify any data type, by default int 32 will be used, guys. Okay. So when I say a dot d type, it will return me int 32. Observe console. Okay. When we are running the lines of code, parallelly focus on the code and the console and the variable explorer as well. And the third attribute that we have is shape. It is shape. What does shape attribute does? Shape attribute will return as the size. It will return as the size of the array. So if I say a dot shape, it will just return me 6 comma. Why 6 comma? We know that it is a one-dimensional array in which there are only 6 elements. See, in A, how many elements you have? How was A created, guys? A was created from the tuple object T. So within this tuple object T, how many elements do you have? 6. Right? So this tuple object was converted to array by using array function from Numpy. Done. In that way, A has been created. So it is clear that it's a one-dimensional array of size 6. Clear? So far we are just, it is just returning as one-dimensional array so far. Now let me use reshape function from Numpy. There is a function called reshape. What is the purpose of this reshape function is, it helps us to perform the transformations. The reshaping can be done. So if you see here, I'm performing the reshaping on array object A. A dot reshape of 3 comma 2. A is a one-dimensional array? Yes. What is the dimension of it? 6 comma. So that means there are 6 elements. So I'm using reshape function. Using reshape, I'm going to make this array object A into 2 dimension. So this 3 comma 2 represents 3 represents rows and 2 represents columns. In general, what are the 2-dimensional objects that we are well known of? Table. A table contains both rows and columns. Right? In the same way, matrix. Yes, a matrix is also represented with rows by columns. In the same way, what I am doing is, I am converting this one-dimensional array to 2-dimension by using reshape function, where I have specified rows as 3, columns as 2. So that means I have to get 3 rows and 2 columns by using these 6 values of A. What are the 6 values that we have in A? These are the 6 values. Okay, so when I use reshape function, what happens is the output will be like 10, 20, the first 2 values, then 30, 40, 50, 60. 3 rows, 2 columns. Done. So we are getting a matrix. In general, a 2-dimensional array is nothing but matrix, right? Yes. So using reshape, a one-dimensional array got converted to 2-dimension. That means, can we convert only to 2-dimension? No. You can convert to n-dimensional array as well. It depends. Okay, the values should support for the conversion, the reshaping. Only then it helps us to return the output. So B will be a two-dimensional array. What will be the output? This will be the output for B. This will be the output for B. In the same way, can you tell me what will be the output for C? Tell me what will be the output for C, guys. Next to the line of B, I'm also converting, I'm using reshape function again on A, but this time it's not actually 3 rows and 2 columns. I'm changing rows. How many rows? Only 2 rows. How many columns? 3 columns. Can you tell me what will be the output for C? Good. The output for C will be like 10, 20, 30, then 40, 50, 60. So this is output of C. How? Only 2 rows, row 1, row 2. But 3 columns, 1, 2, 3. Done? Yes. So when you understand, you can work out on any problem, right? So try focusing on the concepts. Yes, now let me execute, guys. Let me execute both B and C will observe whether our output is correct or wrong. I'm printing B along with its type. So B should contain 3 rows and 2 columns. Let's see. Yes. 3 rows, 2 columns. And what is the type of B? It's an array. It's an NDarray. In the same way, let me print the results of C. Right? Yes. Only 2 rows, 3 columns. Tell me what will be the output for line number 34. Yeah, type function will return the type of the object type, NDarray. What will be the output for line number 34? B dot NDIM, and dimension. What will be the output? Output for line number 34 and 35. The output for line number 34 and 35 will be 2. Why 2? Because it's a two-dimensional array. Both B and C are two-dimensional arrays. No, 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 no. B and C, both of these arrays are two-dimensional arrays. They are not 2, 3. It will be 2, 2. Then, when I say B dot shape, it will return me 3, comma 2. When I say C, comma shape, C dot shape, it will return me 2, comma 3. Careful. NDIM will return us the type of array, whether it is one-dimensional, two-dimensional, three-dimensional, or n-dimensional. Shape will return the size. Okay, right. Now, tell me what will be the output for line number 39. I'll keep it here. I want you guys to answer for line number 39. A is nothing but a one-dimensional array in which it contains 6 values. So this is A, guys. Okay. And I'm using reshape function And I'm converting this one-dimensional array to two-dimensional array where I should have 3 rows and 3 columns. So what will be the output for line number 39? I want everyone to respond. What will be the output? Perfect. Good. Why we will get an exception? What is the reason behind it? How many values we have in A? We have only 6. But when we perform this, when we are trying to use this reshape, we specified that 3 rows and 3 columns. In 3 rows and 3 columns, how many values we have to accompany? We have to have 9 values. But how many values we have? Only 6. So that is where, an exception will rise. So when I execute line number 39, it will raise an exception. See, cannot reshape array of size 6 to 3 comma 3. That cannot be done. Right? So that is where it will return as a value error. Right? Yes. Let us proceed a bit further. So far I am just working on one-dimensional objects like list, tuple, dict, so on. What are we doing in line number 41? I'm defining a nested tuple object. Tuple inside a tuple. Okay, if you observe, we have two tuples inside the main tuple. So this is a nested tuple object T1. Okay, if you observe the size of T1, it is only 2. It is not 4. Okay, inside this nested tuple, we have two different tuples. So when I say print T1 comma type of T1, it will print the tuple object along with its type. It is tuple. Now, I'm using array function. I'm using this array function. Yes, from Numpy, and I'm passing this T1. I'm passing T1 to array so that this tuple object will be converted to array. So what will be the output? Any idea? Any guess? So far we have passed only a one-dimensional tuple. It's not a nested tuple earlier. But this time we are going with a nested tuple. What might be your guess? What might be the answer, guys? Yeah, so it will be a two-dimensional array. Let me print it. See, it will be a two-dimensional array. It will not be a one-dimensional array like similar. Okay, like whatever we have got earlier, it will not return as a one-dimensional array. It is a two-dimensional array. Even if you see here, there are 2 rows and 2 columns. How can you confirm it? We have this attribute called ndim, ndim. So this ndim will return as the output as 2, which means it is a two-dimensional array. What is the shape of this A? It is 2 comma 2. 2 rows, 2 columns. 2 rows and 2 columns. Then let me take one more tuple, but this is also an example of nested tuple. If we see here, within the main tuple, we have two tuple objects, but inside one tuple alone, again there are two tuple objects. Okay, So this is again a nested tuple I'm coming up with, and I'll just print this nested tuple along with its type. It will return the class as tuple. So this nested tuple, I'm just converting it to array. I'm converting it to array using array function from numpy np. So see what will happens. When I do this, this will actually return as a three-dimensional array. It will return as a three-dimensional array. Let me print it. For better understanding, I'll print it. Even if you observe in the variable explorer, A is a three-dimensional array. What is the size of A? 2, 2, 3. In a two-dimensional array, we know if the dimension is like this, 2, 3, we know the first value is representing rows and the second value is representing columns. Fine. But what in case of three-dimensional arrays? Because the third value got added, right? So the first value is talking about the number of matrices. The number of matrices. The second value talks about number of rows. The third value talks about number of columns. So that means rows and columns we have as it is. Okay. Additionally, what got added? Number of matrices. If you observe the variable, the console, I have printed A. So this is matrix 1, this is matrix 2. Matrix 1 and matrix 2. How many matrices should we have? Two matrices. Within each matrix, how many rows should we have? Two. So row 1, row 2 in matrix 1. Row 1, row 2 in matrix 2. In the same way, coming to columns, in each matrix we should have three columns. Column 1, column 2, column 3. In matrix 1, column 1, column 2, column 3. In matrix 2. Everything satisfied? Yes. So A is a three-dimensional array. A is three-dimensional array. So when I use this attribute ndim, the output will be 3. The output will be 3. And shape will be 2, 2, 3 guys. Shape will be 2, 2, 3. So let me anyways print the results. I'll execute both 52 and 53 one by one. See. Yes. Now, can you tell me the output for line number 55? I'm using reshape function. Okay. So I'm using this reshape function. I'll just keep the A here. 10, 20, 30. This is then sorry. The elements got changed, right? 10, 20, 15, then 30, 40, 25. Okay. So this is matrix 1. This is matrix 1. Then in the second matrix, what do we have? 50, 60, 18. Then in the second matrix, second row, 70, 80 and 35. So this is my A guys. This is my A, which is a 3D array. Now, what am I doing? Size of A is 2, 2, 3. What am I doing exactly? I'm using reshape function. I'm changing this three-dimensional array to two-dimensional array. Will it allow me to do it? Or will I get any exception? Yes, I'm converting this three-dimensional array to two-dimensional array. Will it allow me to do it or will it raise any exception? What is your take? What is your guess? Good. It will allow us to convert to a two-dimensional array. It will not raise any exception. Why? The reason behind that is what you are doing here. You are converting a 3D array to 2D array. Fine. Using reshape function. That is also clear. Within this 2D array, how many rows and how many columns we are going to have? 4 rows and 3 columns. Then in 4 rows and 3 columns, how many values you will have? Just multiply them. It is 12 values. And multiply here as well. If you multiply here, even here also you have 12 values. So as the number of values are matching exactly, yes, it will allow us for reshaping a 3D array to 2D array. So this three-dimensional array will be converted to two-dimensional matrix. You will not have this. No more. This is what the output of line number 55. This is nothing but array B. This will be the array of B. Making sense? In the same way, will line number 58 work out? If I go with line number 58, will it allow to convert again to a two-dimensional? Yes, the same process. 3 multiplied by 4, it is 12. So again, I can convert this to reshape it to 2D array. Even this is also possible. But what is the difference between both of these two are? Here, there are 4 rows and 3 columns. But for C, you'll have 3 rows, only 3 rows, 4 columns. See, 3 rows, 4 columns. That is the difference between array B and array C. Okay, so let me execute. Let me execute and show you the differences. First, I'll go with array B, the conversion. Yes, the same output, whatever we have discussed. B is a two-dimensional array of size 4 rows and 3 columns. Done. In the same way, let me also do it for C. C is again a two-dimensional array, but I have 3 rows and 4 columns. Let me print. How it have converted? It will just adjust the values. 10, 20, 15, 30 will be row 1. Next row will be 40, 25, 50, 60. Last row will be 18, 70, 80, 35. Making sense? Yes. Will line number 61 execute or not? 3, 2, 2. I want to reshape array A to 3, 2, 2 array. Will it work out or not? So that means a 3D array, I have a 3D array and I'm also converting it to 3D array only. What are getting reshaped? The values. Internally, the values gets transformed. Perfect. Yes. So what is the difference here? The number of, matrices will increase. How many matrices? 3 matrices will have. Each matrix will contain a 2 by 2 of size. Each matrix will contain 2 rows, 2 columns. Making sense? So let me execute line number 61 as well. I'll print array D of which is of size 3 comma 2 comma 2. See, 3 matrices, matrix 1, matrix 2, matrix 3. This is matrix 1. This is matrix 2. And this will be matrix 3. In all the matrices, it should contain 2 rows. See, row 1, row 2, row 1, row 2, row 1, row 2. And in all the matrices, it should contain 2 columns. Column 1, column 2, column 1, column 2, column 1, column 2. I hope it is making sense. Right? Tell me what will be the output for line number 63, 64 and 65. What we are trying to do here? I hope you remember the concept of indexing. I hope you remember the concept of indexing. Did we discuss indexing so far? Yes. What do you mean by indexing? Indexing is nothing but accessing one value. If you access a single value, a single element, we go with indexing. But indexing we have done on one-dimensional, we have understood on one-dimensional objects like str objects, then byte array objects, byte objects, range object, list object, tuple object, so on. Right? But what is D? Is D a one-dimensional object? No. D is a three-dimensional object. D is three-dimensional object. Right? So when you say D of 0, out of these three, what is the first value that it is representing? It is representing about matrices. 3 is representing about the number of matrices. In the same way, when you say D of 0, it means the first matrix. D of 1 will return as the second matrix. D of 2 will return as the third matrix. Okay, so this is very important. Anyhow, we'll be discussing this in our next class. For time being, you memorize guys. We'll talk about indexing and see. I'll erase all of these. Let me erase, not required. Yes, so when I say D of 0, this will return me the first matrix of D. D of 1 will return the second matrix of D. D of 2 will return me third matrix of D. Okay, so how and all we'll discuss when we talk about the concept of indexing and slicing. Especially in Numpy, we have a topic called basic indexing and slicing and advanced indexing and slicing. Okay, so we'll be understanding, that's not an issue. I hope we are very clear on array function from Numpy. So let us also discuss about Arange. The next function that we have for creating the NDarray objects is Arange function. So what is the purpose of this Arange function? How do we use it? Is, again, there are three syntaxes for Arange. Arange, it is not A double R. Don't use A double R. It is Arange. Keep it, clear. For using Arange function, we have three different syntaxes. Let us understand all these syntaxes. Numpy.arange of value, numpy.arange of start comma stop, numpy.arange of start, stop and step. Hold on. I think these are again similar to range syntaxes. Even if you remember range data type, we discussed three different syntaxes: range of value, range of start comma stop, range of start comma stop comma step. In the same way, we have three syntaxes for arrange. Let us understand what the syntax one says. Syntax one says it helps us to create an n-dimensional array object where it starts from by default 0 till value minus 1. Till whatever the value that we specify, okay, till value minus 1, it creates the elements from 0 to value minus 1. What does syntax 2 says? It says that it creates an n-dimensional array object. The elements, the values will start from the start value till stop minus 1. See? And syntax 3 says to create an n-dimensional array object, it also creates an n-dimensional array object, but the value starts from start and it ends at stop minus 1. But these values will have an equal interval, that is step. Whatever we specify here, excuse me, whatever we specify here as step value, that will be used as an equal interval. Right? And Arange function always creates only one-dimensional arrays only. This is very important point that we have to keep in mind. Arange function will create one-dimensional array objects only. What does it mean? It means it does not return us a two-dimensional or multi-dimensional arrays. How can you do it? Again, we go and use reshape function only. From the output of Arange, which is returning as a one-dimensional array, I'll use this reshape function on this and I'll be able to create multi-dimensional arrays. N-dimensional arrays are possible. Okay, so that is what we do. But keep it in mind, Arange function from Numpy will always return only a one-dimensional array as output. Okay, so let us look after the hands-on part immediately. What are we doing in line number 73? I am importing Numpy. Initially, why am I importing Numpy? The reason behind why am I importing Numpy is we know that Arange comes from Numpy. Arange comes from Numpy. So in order to use Arange function, we have to first of all go and import Numpy. So I'm importing Numpy as NP. Done. A shortcut name is also provided. So instead of Numpy, every time I'll keep it as NP. NP dot arange of 10. What does it mean, guys? Which syntax it will be part of? It is part of syntax 1. NP numpy dot arange of value. Right? So this will create a array object. Excuse me. Starting from 0 till value minus 1. So that means it creates a array, one-dimensional array object of values starting from 0 till 9. Till 9. Okay, so let me execute and cross check whether I am correct or wrong. See, the moment I have executed, it created me an array object which is of one-dimensional array. It's a one-dimensional array. The values by default start at 0 and it generates till value minus 1. 10 minus 1 is 9. Right? So this is my one-dimensional array object. Let me print A to the console. So this is my array. And when I say a.ndim, ndim is an attribute which returns the type of array. What type of array it is? One dimensional. So it returns 1. In the same way, tell me the output for line number 78. 78. NP dot arrange of 50 comma 62. I'm using syntax 2. I'm using syntax 2. What is the start value? 50. What is the stop value? 62. So it starts at 50. It ends at 61. Right? So the output will be from 50 to 61. Let me print it. See. No, it stops at 61 only. It stops at 61 only. Right? So when I say n dot ndim, the output will be 1 again. It's a one-dimensional object. One-dimensional array object is what Arange function creates. In the same way, let me go with syntax 3. 10 comma 23 comma 2. Come on guys, what will be the output? Start, stop and step. It starts at 10. The next value will be 10 plus 2, 12. 12 plus 2, 14, 16, 18. We know it has to stop at 22. Right? 20, 22. So this will be the output for, yeah. So we'll have an interval of 2. So this will be my array. This will be my array. Let me print the results. I'll execute line number 82, then followed by 83. See. In the same way, output for 85. Output for 85, line number 85. It will not return 22 guys. It starts at 10. The next one is 12, 14, so on till 20 only. The reason behind is, yes, it has to stop at 21 itself. And we know 21 cannot be returned. We cannot achieve 21. Okay, so here we will just achieve only the even numbers. So it will stop at 20. Good. Then, see, as we have discussed, the range, the output of a range is again a one-dimensional, right? So this one-dimensional array, I'm converting it to two-dimensional using reshape function. Okay, so I'm going to get a two-dimensional array of 2 rows and 3 columns. So will it allow me to do it? Yes, it will allow us to do it. So what will be the output for line number 88? 10, 12, 14, 16, 18, 20. So these values we are going to convert to two-dimensional. It will not return any error. It will execute. See, here I have 6 values and I am also going to get 6 values only, right? Why it will return me error? It will not return error. The output will be 10, 4, 12, 14, 16, 18, then 20. So this will be the output for, this is the output of array, two-dimensional array B. Let me execute guys. So when I execute, I'll get a two-dimensional array as output and I'll print it to the console. See. And when I say NDIM, it will return us the value as 2 because it's a two-dimensional array. B is a two-dimensional array. And B dot shape will return me 2, 3, the size of B, array B. In the same way, I'm using reshape function, but this time 3 rows and 2 columns. Will it allow me to work on the reshaping of A to 3 rows and 2 columns? Yes. Yes. But instead of earlier we had 2 rows and 3 columns. Now we are going to have 3 rows and 2 columns. I'll print the C array to the console, array C to the console, done. And DIM will return us the output as 2, shape will be 3, 2. Done. And finally, what am I doing here? What is this? This is a nested list object, right? List inside list. We can clearly see this is a nested list object. And let me print this nested list object to the console. And I'm passing this nested list to Arange function. Will it return as a one-dimensional array or will it throw any error? What will be the output for line number 101? Because for arrange function, we have discussed 3 different syntaxes. What are they? Arrange of value, arrange of start, stop, arrange of start, stop, step. But here I am passing a nested list object. Will it allow me to return a one-dimensional array or not? What is your call? What will be the output? The output will be an exception. Why it is an exception? See, here it is unsupported. It is not supporting. The reason behind is you are supposed to pass only these values. And how can you pass any other objects? No, right? Yes. So the output will be an exception. So this is all about arrange function. The second function that we have is arrange. Let us go with the third function, that is zeros. The third function is zeros. What is the purpose of this zeros function? Let us understand now. The zeros function will help us to build a zero matrix. It helps us to build a zero matrix either of one dimension, two dimension, or n dimension. Either of one dimension, two dimension, or n dimension. And the syntax for zeros is numpy dot zeros of shape comma d type. Okay, we have to specify the shape. The shape can be one dimension or two dimension or n dimension also. Okay, if you want only a one dimension zeros, an array with only one dimension zeros, you just specify the number of zeros here. If it is a two dimension matrix is what you want, then you have to specify rows and columns as input for shape. If it is a three dimension array, you have to specify number of matrices, number of rows, number of columns. In this way, you have to specify all the dimensions for the shape. Right. So let me go with the hands-on, the examples. We know that the zeros function is going to build as a zero matrix. And depending on the shape value that we pass, accordingly it is going to return us the output. See, Initially, I am importing numpy as np. Okay. Next to it, I am using zeros function from numpy. Okay. In which I am just passing only one value, which means it is going to return as a one-dimensional zero array. Okay. It returns as a one-dimensional array of zeros. How many zeros? 12 zeros is what I have specified. So it will return as 12 zeros in a one-dimensional array. A will be a one-dimensional array. C. But instead of 0, I see 0 point. Instead of 0, I see 0 point. That is because of the D type, guys. By default, the D type will be float. Okay. If you don't change the D type to int, see, I'm specifying here. What is the difference between line number 1081, 11111 is data type. If you don't specify, it takes the data type as float. That is why you see the output as 0 point, 0 point, so on. All the values are in decimal values. But here I have specified as int. This time the values will be only 0, comma 0. See, you'll not find any decimal values for the zeros. No. Clear? So if you have to get the zeros in integers, int values, it is recommended. You have to go with the D type as int. The data type should be int. Fine. Again, it's your turn. I'm performing reshape function. Okay. On A. So will it allow me to perform reshape? 3, comma 4. I have A, which is a one-dimensional array. Okay. And the size is 12 comma. That means we have 12 zeros. Right. Now I am using reshape function and I want to reshape it to two-dimensional array of 3 rows and 4 columns. Will it allow me to perform or not? The reshaping can be done or not? The reshaping will be done? Yes. I'll get 3 rows and 4 columns because 3 multiplied by 4 is 12. Right? So the output will be, all of them will be zeros and it contains 3 rows and 4 columns. All of them will be zeros. Yes. In the same way, 4 comma 3, 4 comma 3. Even 4 comma 3 also I can reshape. 4 rows, 3 columns. Anyhow, how many values? 12 values, right? So it will allow us to reshape. 6 comma 2. 6 rows, 2 columns. Will it allow us to reshape? Yes. Why? If you see here, what is the product that we get here? 6 twos are 12. Do we have 12 zeros? Yes. Do we have 12 zeros? Yes. So this will return as a two-dimensional array with 6 rows and 2 columns, and all of these values will be 0. 2 comma 6? Yes. Only 2 rows, 6 columns. Okay, fine. What about line number 122, guys? 2 comma 3 comma 2. 2 comma 3 comma 2. Two matrices, okay, and each matrix with 3 rows and 2 columns. Will it allow us to return, can we reshape a one-dimensional array A to a three-dimensional array? Yes or no? What is the product? 2 threes are 6, 6 twos are 12. So again, it helps us to reshape. This is how the output will be. Two matrices, matrix 1, matrix 2. And in each matrix, it should contain 3 rows and 2 columns. 3 rows, 2 columns. 3 rows, 2 columns. Good. Line number 124. A dot reshape of 2 comma 2 comma 2 comma 2, which means a 4-dimensional array. Will it allow us to convert to a 4-dimensional array? For line number 124. Is that possible? No. Why? No. Good. Why? The reason behind it is when you try to multiply all these values, you'll get the product as 16. But how many zeros we have in A? We just had only 12. Okay. So that is where it raises an exception. It raises an exception for line number 124. See. Cannot reshape array of size 12 into shape of the specified shape. Good. What about line number 126? Yes, I can. 3 matrices. Each matrix should be a 2 by 2 matrix. 2 rows, 2 columns. Yes, this is also possible. See. Matrix 1, matrix 2, matrix 3. All of the matrices are 2 by 2. Done. Line number 128. Yes. 2 matrices. Each matrix should contain 2 rows and 3 columns. This is also possible. Simple. If you understand the concept, okay, it will be very easy for you to answer any question. I'll talk about 4D matrices also, 4D arrays also. Okay. As we go on, I'll talk about 4-dimensional arrays. You need not focus on that for time being. Right. So let me proceed to the next line of code. I'm importing Numpy again, once again. Then what am I trying to do here? I'm going to create a 2-dimensional array using zeros function. Okay. So this will return us 3 rows and 3 columns where the D type is int, which means all these zeros will be, they don't contain any decimal values. Okay. So this will be a 2-dimensional array. See. In total, 9 zeros is what it returns us. Good. What about line number 134? Yes, we are going to create a 2-dimensional array using zeros function, which contains 2 rows and 3 columns. Okay. All the values will be 0. So 0 matrix. But as we did not specify the D type as int, it will return us the values in decimal points, the floating values. Next to the line. I'm using zeros function again. The same code, the only difference is D type. So if I specify int, the output will not contain, the values will not contain the points, the decimal values. And finally, we are creating a 3-dimensional array using zeros function. Okay. So I'm using a 3-dimensional array. I'm going to create a 3-dimensional array which contains 3 matrices, and each matrix will contain 2 rows and 3 columns. And all the values will be 0. Why? Because we are going to use zeros function from Numpy. So the values again will be of int type. See, this is how the output will be. I hope it is very clear, guys. Right? So one of the approach of creating arrays is n-dimensional arrays can be created using zeros function from Numpy is what we understood. Next to zeros, we have one more function called ones. There is a function called ones. Now let me talk ones. If we are clear on zeros, ones is not a big task for us. It is similar to zeros function, but the only difference between zeros and ones is instead of zeros, it will return as a ones matrix. In zeros function case, it returned as a zeros matrix, but in case of ones function, it returns ones matrix. It can be of one dimensional, two dimensional or n dimensional matrix. I mean, the arrays can be written. So upon the shape, whatever we specify the shape, accordingly, it is going to return as the n-dimensional array object. Okay, similar, but the difference you'll observe in the values. Here it will return once. Right. So let me go with the hands-on part of once. Yes. So let me import NumPy initially. First of all, I'm importing NumPy as NP. Then let me go with one-dimensional arrays, creating one-dimensional array objects using ones function from NumPy. So np dot ones of 10. What does that mean? That means this will return a one-dimensional array which contains 10 ones. Because I just mentioned only one value, right? So this will obviously, it can understand that it is a one-dimensional array is what we are expecting. So it contains 10 ones and we did not specify the D type. When we did not specify the D type, obviously the D type will be, the default one will be float. The default one will be float, right? So the difference between the previous line and this current line is I'm changing the D type to int. Will not have the floating values, guys. See, all of them will be int type values. All the ones will be of int type. How many ones? 10 ones. So when you say a dot shape, it will return as 10 comma because it is a one dimensional array. And when you say a dot ndim, it will return the output as 1. Why it's a one dimensional array? What if I want to have a two-dimensional array? Specify the dimension. You specify the dimension accordingly inside the ones function. No, it has written as 10, right? Do you see 9? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Clear? Okay. Right. So if you observe, now I am trying to get a two-dimensional array of size 3, comma 4. 3 rows and 4 columns where the D type is int. So all the ones will be of int type. So this will return me a two-dimensional array. Let me print it. See. 3 rows, 4 columns. In the same way, what am I doing next to it? I'm using the same ones function. Okay. So this ones function is going to generate a two-dimensional array of size 4, comma 3. 4 rows, 3 columns. And the ones will be of type int. See. 4 rows, 3 columns. And when I say a dot shape, the output will be 4, comma 3. Today we are just concentrating on how to create array. NDarray objects, how to create is what we are understanding. As we move on, NumPy is one of the important, package that one has to learn. Okay. So for sure you'll get some questions, guys. Pay attention. What am I doing in line number 165? I'm using ones function Yes, we are using ones function, and what type of array it is going to return as? It will return as a three-dimensional array. Why? We have specified three dimensions, right? Number of matrices, number of rows, number of columns. As we specified three dimensions, this will return me a three-dimensional array. And the D type is int. So let me do it. A will be a three-dimensional array object. See, four matrices, matrix 1, matrix 2, matrix 3, matrix 4. Each and every matrix has three rows, three columns. Now, I'm performing indexing and indexing concept in different ways. Okay, even though if you don't understand, that doesn't matter here, because we'll be focusing on indexing and slicing in the next class, because we are not having good amount of time. So this is just a sample. A of 0, then again 0 and 0, which means in the first, A of 0 will return as what? The first matrix, this matrix. In the first matrix, again, we are representing 0, which means the first row. Again, we are representing 0, which means the first column. So that means what is the value that we have there? It is 1. So when you execute line number 167, it will return as 1. See? 1. This is basic indexing. We also have advanced indexing. I'll talk the differences. Okay, that's not an issue. Here, the output will be the same one, but what you have to understand is this is representing matrices, this is representing rows, and the next 0 is representing columns. Okay, so this is advanced indexing. You'll understand in the probably in the next topic. So when I say A of 0, comma 0, comma 0, again the output will be 1. Yes, the output will be 1. Right. A of 0 will return as the first matrix. This entire matrix will be returned. And in this matrix, I want the element which is at 0th index. I mean, from the 0th row index and 0th column, 0th index column. What is it? It is 1 again. So, I'm able to retrieve 1 in 3 different ways. Okay, so this is where you'll understand the concept of basic indexing and advanced indexing. Okay, we'll understand this. Probably in the next class, we'll be understanding. Let us go with the next function called full. What does full function does? Full function, so far we understood zeros function and ones function. Both these functions we have understood. Next to ones function, we have full function. What does full function does? Full function helps us to build a matrix by whatever the fill value that we specify. Okay. By using this fill value, it is going to return as a array. And this array can be of one-dimensional, two-dimensional or n dimension. The syntax for full function is shape. Shape is mandatory, and the fill value, whatever the fill value that we have to use for filling the values of the object, that has to be used, and the d type. Zeros function is using 0, ones function is using 1. But full function will use fill value. This value will be used. Okay. So let us focus on the hands-on part. What am I doing here? I'm using full function. Yes. np dot full of 3 comma 1. What does 3 means? 3 is representing shape. That means it is a one-dimensional array. It is what creating here. But the fill value is 1. 1 will be used to fill the one-dimensional array. So 1 will be used for tries. 1 will be used for tries to return as a one-dimensional array. See, it returned me a one-dimensional array. All of them are ones. Why they are 1? Because the fill value is 1. What if I want to change the fill value? See, this will return me again a one-dimensional array only. But the fill value is 9. I hope you are getting the point. Just map the syntax. The fill value is 9. What if I want to get a one-dimensional array but the fill value should be 8? Just keep the fill value as 8, and for how many times you want this value also you have to specify since it is one-dimensional. So I just kept it as 6, 8, which means for 6 times 8 value will be filled and it will return as a one-dimensional array. See, 6. 1, 2, 3, 4, 5, 6. Yes. In the same way, one-dimensional array where the fill value is 9. Okay. And how many times? 6 times. I hope you are getting the point. Right? So this I'm reshaping. I'm using reshape function and I'm changing the size. A one-dimensional array, can I convert it to two-dimensional where I have 2 rows and 3 columns? Yes, it is representing int by default. Even though if you don't specify here, the d type is taking int. But in case of ones and zeros function, the d type by default will be float. Okay. So when I say reshape of 2, 3, it will go, will it execute? Yes. The reason behind is we already have 6 values and you are also trying to convert into a two-dimensional array of 6 values. So this will execute. This will execute. Then next to it, I'm creating a two-dimensional array of size 3, 3, 3 rows and 3 columns where the fill value is 9. Can I do it? Yes. What is the purpose of full function? Full function will return us n-dimensional array object, okay, by specifying the shape and the fill value. Okay. So when you specify it, you'll get the output as a two-dimensional array object. 3 rows, 3 columns. In the same way, what is the fill value? 6. The fill value is 6. What I'm trying to get here? I'm trying to get a two-dimensional array. 2 rows and 3 columns. Yes. 2 rows, 3 columns. Okay. And finally, I'm using reshape function where I'm converting this A to two-dimensional array, but which contains 3 rows and 2 columns. Okay. So when I use this reshape, will it help us to reshape? Yes. Because we already have 6 values, right? This will perform the reshaping. And one example for a 3-dimensional array using full function. Can we also generate 3-dimensional array? Yes. Specify the shape accordingly. When you specify the shape, number of matrices, number of rows, number of columns, and the fill value. If you provided all these particulars. Okay, when you provide all these values to the full function, this will return us a three-dimensional array. Let me print it. See, matrix 1, matrix 2 and matrix 3. Clear? So this is all about full function. We also have one more function, guys. It is identity function. Okay, I'll explain identity function so that we'll complete the number of approaches topic. So what is the purpose of the identity function? Identity function, like how we have used zeros function, ones function and full function, in the same way, identity function also helps us to build these arrays, ND arrays. Okay, especially it helps us to build identity matrix. Are you guys aware of identity matrix? What is an identity matrix? Identity matrix is a square matrix in which the diagonal elements are 1 and rest of the non-diagonal elements are 0. Right? So what is a square matrix? Square matrix means a matrix in which both rows and columns are same. The number of rows and the number of columns are same. Such kind of matrix is called square matrix. So that means an identity matrix is always a square matrix in which it contains only the principal diagonal elements as 1, rest of the non-diagonal elements as 0. That is the purpose of identity function. Okay, even if you observe the syntax for identity, numpy dot identity of n comma d type. What is n representing? N takes either rows or columns. Either if you specify one value, that is enough, guys. Okay, when you specify either rows or columns, that is enough because we know that rows and columns both are same. Right? Yes. So let me go with the identity matrix use case. Hands on. Right. So I'm importing numpy as np. Then I'm using identity matrix function from numpy. Okay. And I'm also going with how many rows I have specified here. What is the value of n? I have specified the value of n as 3. I have specified the value of n as 3. That means I'll get 3 rows and 3 columns. Where the d type is int. So that means all these values will be of int type. So this will create an identity matrix. See? This will return me an identity matrix. Only the principal diagonal elements will be 1. The rest of the non-principal diagonal elements will be 0. That is what it is called as identity matrix. What is the purpose of identity function? It helps us to return as an identity matrix. Can I also change the value for n? Yes, you can pass any value for n. What does n represent? N represents the number of rows or the number of columns, because for a square matrix both are same. So when I say np dot identity of 5, so what am I going to get? I'll get 5 by 5 matrix. See, I'll get 5 by 5 matrix. Only the diagonal elements will be 1, the non-diagonal elements will be 0. Right? So this is all about the number of approaches for creating ND objects, NDarray objects from NumPy. Okay, so I'll stop it here. Now let me move to Just give me a minute. Right. So as we have discussed, let us talk about the internship program that Nextera Unitech is providing. Okay. So without no further delay, let's get started, guys. Right. So what exactly are we going to understand with respect to the internship? Okay. So before talking about internship, I would like to talk about, I would like to discuss about what is Nextera Unitech. Okay. Then next to understanding Nextera Unitech, I'll also talk about internship because majority of us, we are not clear on the definition of internship. Right. So we'll be clear on what exactly is internship. Then what are the phases of internship that we include as part of our internship program? We'll talk about the phases. And finally, next to the phases, we'll talk about the hands-on projects. Okay, what the projects that we are going to give, what are the skills that you are going to gain. And next to the projects, we'll talk about the certifications and finally our career opportunities. So we'll be understanding all of them together. Okay, so this is a demo session for internship batch 6. So guys, pay attention. I'll take all your questions at the last. Okay, so don't interrupt me. Right. So what exactly? Who are we? Next Era Unitech. Next Era Unitech is an edutech platform, okay, where we provide comprehensive trainings in the space of data analytics, data science, artificial intelligence. Then we also have the trainings related to Python. In future, we are also trying to bring trainings related to IoT, embedded systems, and many more. Okay. So we also have a industry focused curriculum. Okay. We have designed our curriculum in such a way that majority of our applications are related to the real world, guys. In such a way, we have designed our, curriculum for all these courses. Then, next to this curriculum, we also ensure that we mainly focus on hands-on learning because this is what majority of us we are not good at. We focus mainly on the hands-on learning part, okay, where we focus on the project simultaneously. Okay, project knowledge is very important, right? So as part of your course, we also focus on your projects. Apart from our course trainings and projects, we also provide free internship programs. We provide free internship programs and these are industry recognized. Okay, so the reason why we have gathered is to understand what kind of internship we are providing. Am I right? Yes. So let us understand what is the meaning of internship. What do you mean by internship, guys? If someone asks you a question like, what is internship? What will be your answer? So we have defined internship very beautifully here. Okay. So try to focus. Internship is nothing but, gaining real world experience. Okay. Parallelly completing your work and focusing on real world experience. Okay. Where you get an opportunity to work on the projects. Okay. Which will enhance your problem solving skills. When you work on projects, obviously, what happens? Your problem solving skills will enhance, right? And simultaneously can develop your network. So this is how we define internship. So we have designed our internship program in such a way that, it contains some phases. There are some structured phases for our internship. Okay. Initially, we'll have an orientation session, probably on the next day, tomorrow. Then, next to the orientation session, we'll discuss about our learning phase. Okay, we'll have a learning phase where we'll be focusing on some skills. Okay, everyone who is part of the internship, okay, they'll get a in-depth knowledge of these core concepts. And across these learning phase, you'll have a mentor. Mentorship will be provided. Okay, so you'll get continuous guidance from these experts. And next to the learning phase, you'll have hands-on project phase. Okay, so you are the one who has to develop an end-to-end project. Okay, so this is an overview of our internship phases. And as part of our orientation session, we'll be talking about the tools and the expectations from you. Okay, in the next session, probably tomorrow, I'll be explaining what kind of tools, the skills, you're going to get from this internship. What softwares you have to install. Okay, what all things you are going to learn, what skills you are going to focus on will be covered as part of our internship orientation, right? Let me talk about the learning phase. Coming to the internship details, initially we'll have the learning phase for 30 days, guys. We'll have the learning phase for 30 days, where every one of us will be learning the skills related to Python, EDA, data cleaning, SQL, and Power BI. Okay, so all of us, we are going to learn 5 different modules. All the 5 different modules are very important. Next to these 30 days, we are also focusing on project phase. We'll be focusing on project phase. So this project phase will be for 15 days. And as part of project phase, we'll be assisting you. But no kind of spoon feeding will be done. We'll not spoon feed you, but we ensure that you complete your project. And as part of learning phase, we'll be connecting on daily basis and we'll be discussing about the topics that we learn on each and every single day. Okay, so it depends on the strength. Probably it may go beyond 1.5 hour per day. And are you worried about the fee? It is absolutely free, guys. We are not going to charge even a single rupee from your pocket. Okay, it is completely free. Utilize this opportunity. And coming to the certification, at the end of the internship, you are going to achieve a free industry recognized certificate from NDarrays Unitech. You are going to get a free industry recognized certification. Right. Let me talk about the career opportunities. Okay, before that, we have certification. Yes. So what if you achieve a certificate on your internship? Upon your successful completion of internship, yes, You are going to receive a certificate from NextEra Unitech, and this will add a lot of credibility. Okay, especially if you are a fresher, if you are looking out for job opportunities. Yes, so this will actually make out you to stand in top one. You'll be standing on the top. The reason behind that is you have done your internship where you can showcase your skill related to your project. Yes, you can add, this will actually increase your weightage in your resume. Right. Next to certification, let me talk about career opportunities. As we know that AI is in boom, and whatever the skills that we are learning are also related to AI. Right. If you see Python, SQL, okay, then Power BI, data cleaning, EDA, then we also have machine learning, deep learning. All of these are nothing but the skills that are primarily required for AI related roles. Okay, so in short, you are actually getting ready for your job, and there is a lot of demand for these professionals. For data professionals, there is a lot of demand. If you don't trust me, guys, you can go and do a kind of research. Do Google search. Okay, you'll come to know whether there is a industry demand or not for the data professionals. So that is where we are making you ready for the jobs, right? And finally, one point from my side. So are you ready to start your career? Then utilize this opportunity. Don't, you know, sit back and relax. This is the right time to start your career. Okay. If you are looking out for the best opportunity, here it is. NextEra Unitech has come up with the internship program. Utilize this program. Okay. So the rest of the details will be communicated in the groups. Especially do join the orientation session tomorrow. As part of the orientation session, you'll get all the details, especially, uh, the source of the platform for communication. So all these details will be provided in our orientation session. Okay. So apart from this, if you are having any other questions, yes, feel free to ask questions. It might be related to our internship or even our lecture. Any questions? Yeah, students from any domain, any discipline can join this internship. Okay, and you can upskill yourself. We are here to help you. Okay, so all the upcoming details will be shared in our next session, that is orientation session. So do attend that without fail. Irrespective of your domain, you can join and you can learn. It's MSME approved. Any other questions? Don't hesitate, guys. Keep questioning. Yes, obviously. Yeah, you can add these projects in your resume, your portfolio, wherever you want, you can do it. Any other questions? And guys, if you find the session went well, do hit on the like button and share across your connections. Yes, the feedback link has been provided. Please provide your valuable feedback before you leave. Once again, thank you so much, guys, for joining and making the session wonderful. Do hit on the like button, encourage us. Have a great day.